Hey everybody, welcome to 8.6, the logarithm equations. So much like 8.5 where we solved exponential equations, we're finding x. 8.6 we're going to be starting with logarithm equations and also still trying to find out x. So you'll remember from the last section, the ways that we were able to solve our exponential equations were, we either got a common base or we took the natural log. So what we're going to find out in this section is that we can either try to get the common base and match up the left and right sides, whatever's the same. Or we're going to try to, instead of taking the common log, we're going to put it into exponential form and see if we can solve it that way. So kind of the same idea, either get a common base or change the form. 8.5, we changed it to logarithm by taking the natural log of both sides. And in 8.6, we're going to start with the log and put it back into exponential form, potentially. Both are fine. So today we're going to continue solving equations, but we will start with equations in logarithm form. So the first one that we see here, it says, common methods are to, if the base is the same on both sides, equate the parts that are the same. So the first one says log 5x is equal to log 520. So we're going to equate both sides. X is in the spot of 20, so x must be equal to 20. Right, that's the first one. So we're just going to put what's equal together. Second one, same idea. So I see the argument here is 2x minus 4. The right side is 36. Both have the same base. That's what we need. So I know that 2x minus 4 is equal to 36. And I'm going to solve that one the rest of the way through. Bring 4 over to the other side. We add and divide both sides by 2. X is equal to 20. So for the third one, there's a little bit of a typo because we want to start with the common bases for now. So it doesn't matter what we call it, but let's make the second one have a base of 3 as opposed to 15. And this one here also have a base of 3. I don't know what I did when I was making that. So let's continue through. Sorry about that. But for this one, what we're going to do is we're going to get our log x by itself. So I'm going to leave it over here on the left side. Log 3x is equal to, on the right side was already log 310. And I'm going to bring over log 3, 4. So I'm going to subtract log 3, 4. So now in this case, I can combine those ones on the right side, because remember, if we're subtracting two logs with the same base, we can divide their arguments. So this becomes log 3x is equal to log 3, 10 divided by 4. So now I look at the left and the right side, they both have the same base of 3. I see that x is the argument, so x must be equal to, well, 10 over 4. Or 2.5. But that's that one. Sorry about the basis for the original question that we started with. Meant to fix that one. Next, what happens if we have only one side that has a log? So I obviously can't put that one into both log on the left and right side and equate their parts of the equation. So what I'm going to have to do is convert it to exponential form. So the exponential form of what's written here is, well, I have a base of 7. I have an exponent of 4 is equal to x. Now that's a lot easier to solve. X is already by itself. I just put in my calculator 7 to the power of 4, which is 2,401 is equal to x. That's it. So if I have log on one side, just change it to exponential form. If we have log on both sides, well, we can equate them to be the same. And then it says, finally, once we find out the value for x, we need to determine if the roots are admissible. We cannot have a root that would make a negative argument in the logarithm with a positive base. So for example, this one here, we had 2,401 as my x. It can go here. I'm allowed to have a positive number there. I can't have a negative number there. Also, I can't have a negative base for logarithms, We're only working with positives here. So once we get our answers, we have to check, are they okay? Can we have them? Do they work? So let's go through the first one here. So log 6 with an argument of x minus 7 is equal to 2. So I see a log on one side. Immediately I know I'm going to put that in exponential form. 6 to the power of 2 is equal to x minus 7. I have 36 is equal to x minus 7. And I'm going to add 7 to both sides, so I'm going to get x is equal to 43. Now I say, does that make sense? Can I have an answer of 43? Well, the argument 43 minus 7 is a positive number, so we're okay with that. Let's keep going. Next one, I see that we have log 3x is equal to 3 log 3, 5. So you might say, well, how do I work with this? Maybe what you think is, I'll put all this into my calculator, I'll get a number, and then I'll put it 3 to the power of that number is equal to x. Sure, you could do that. But we have a little bit of a faster way. Remember that the power rule. Log 3x is equal to, this 3 can go on the exponent here. Right, 5 to the power of 3. Right, simplify it for ourselves. Log 3, 5 to the power of 3. So now I look at my equation, I see left and right side both have the same base, so I know x must be equal to 5 to the power of 3. I know x must be equal to 125. And done. Had I put all that entire right side into my calculator and then convert it to exponential form, that's fine too. You'll also still get 125. It's a little bit more work, but it doesn't matter, you'll get there. All right, keep going. Log 5x is equal to log 5, 9 minus log 5, 3. Well, on the right side, I see we have a subtraction of logs. And remember, when we subtract the logs, we can divide the argument. So log 5x is equal to log 5, 9 divided by 3. Log 5x is equal to log 5, 3. So I look at those, left and right side have the same base, so x must be equal to 3. And fourth one here, I see a log on one side of the equation. I know immediately I'm going to put that into exponential form. 5 to the power of 2, right? Base to the power of exponent is equal to argument 2x minus 3. Continue through, 25 is equal to 2x minus 3. When I bring 3 to the right side, I'm adding 3 to both sides. So I'm going to get 28 is equal to 2x. And when I divide, I get x is equal to 14. Now, all of these were admissible. We were okay with them, right? X is 25. I can put it in here. I can have a positive argument. That's good. X is 3. I can put it in here. I can have a positive argument. That's good. 14. I can put it in here, right? It's going to be 2 times 14, which is 28. 28 minus 3 is 25. That's okay. I'm allowed to have a positive argument of 25. We just can't have negatives there. If that's true, if that happens, we're going to have to cancel it, and you'll see that as we continue. All right, keep rolling along here. This one here has a log on both sides, natural log on both sides. So what I'm going to do is I'm going to get all our logs on one side. So I'm going to take all the x's, bring them all to one side. So maybe to the right side. Doesn't really matter, but 1 is equal to, well, log x plus 5 plus log x minus 4. It didn't matter what side I bring it to, but now at this point, I have logs with the same base adding together. So remember what that means is that I can multiply the arguments together, right? That was the product rule. So 1 is equal to log x plus 5 times x minus 4, right? I can use binomial distribution. When I distribute that through, we're going to get x squared plus x minus 20. So now we look at this and say, okay, I see a log on one side of the equation, not on both sides. So I'm gonna have to put this into exponential form. So remember, this log, there's nothing there, so it's assumed that it's 10. So it's really 10 to the power of 1, right? 10 to the power of 1 is equal to the argument, in this case, x squared plus x minus 20. And now I can solve this one. I can bring 10 over to the other side, right? And we solve our quadratics. This is just a quadratic equation. X squared plus x minus 30, right? 10 comes over to the right side. We're subtracting 10 from both sides. Now I can factor two numbers that multiply for negative 30 and add for 1, or 6 and 5. So x plus 6 and x minus 5. And when I solve it, now I look at these, I say, well, x is equal to negative 6 and x is equal to 5. But we're going to have to see if both of these are admissible, whether we can have both of these roots. Because remember, the arguments can't be negative. So let's take the one on the left side here. Negative 6. If I put negative 6 into this spot here, that logarithm's going to be undefined. I can't do that because I'm going to have log negative 10. I also can't do it over here because I'm going to have log negative 1. Doesn't matter that as long as it's not allowed in one of them, that root is immediately thrown out. So that one, inadmissible. Can't use it. Let's see, x is equal to 5. Can I use that? Well, this log here, sure, log 10, that's fine. And this one here, if I put in 5 for x, log 1, that's fine as well. So that root is admissible. So there's only one answer to this one. X is equal to 5. The other root, we can't have that one. And we talked about that in an earlier lesson, why that's not possible. Because we have a positive base, if you're not sure. Remember, we have a positive base of 10. So we're saying 10 to the power of something is equal to the argument. So I can't have like negative 10. You can't have an exponent that would lead to a negative number on a positive base. All right, let's keep going here. Next one's very similar. Everything's already on one side for us. So I see two logs with the same base on the left side. So I know that I can multiply their arguments, x plus 2 and x minus 1 is equal to 1. So when I expand that one through, x squared plus x minus 2 is equal to 1. Now we have a log on one side of the equation, so I'm going to put that into exponential form, right? So remember, it's a natural log, so 10 to the power of 1 is equal to x squared plus x minus 2, right? That argument. Right, if you forgot, the whole idea is you have log ax is equal to, or log ay, I should say, is equal to x. All I did was put that into exponential form. So the base, in that case, was 10. Whatever it's equal to, that's my exponent, 1, is equal to y. Right, so just a quick overview. This is my a, 10. That's where I got a here. This is my x, that's my exponent. That's why it's up top here. And all of this is our y, that's our argument. That's why it's all on the right side. So that's our new equation. Now we have a quadratic that we want to solve. So I'm going to have to bring all the values to one side. So when I do that, I'm going to be subtracting 10 from both sides. So I'm going to get negative 12. Now I factor that. Two numbers that multiply for negative 12 and add for 1 are 4 and negative 3. X plus 4, x minus 3. That leaves me with x is equal to negative 4. And x is equal to 3. So I have two roots, and I want to see, are they both admissible? Sometimes they're both okay. Sometimes none of them are okay. So let's take negative 4. First one here. Doesn't work. Log negative 2. Can't happen. I can't have a base of 10, right? It's log 10, to any exponent that would leave me with negative 2 as the answer. So that's why it's inadmissible. It doesn't work. So that first one can't happen. How about the next one? 3. Whoops, I'll go back to that color. 3, it can go into this log here because it'll be log 2. That's good. 3 can go into this one because it'll be log 5. That's also good. So we do have one root to this answer, which is x is equal to 3. All right, 2 more to look at here. Now this one here, right off the bat, we have log on both sides. That's good. So I can just equate these together. Right, x plus 5 is equal to x minus 1 squared. Right, didn't really have to do any work. I could expand just like before, so you know how to solve these ones. When I expand that binomial x minus 1 squared, we get x squared minus 2x plus 1. And I bring all my values to one side. Doesn't matter if it's left side or right side. Maybe I'll bring it to the right side because x squared is positive on that side. Minus 3x because I'm subtracting an x, and I'm subtracting 5, minus 4. And then I factor it. Look for two numbers that multiply for negative 4 and add for negative 3, which are x minus 4 and x plus 1. Find my answers. X is equal to 4 and x is equal to negative 1. And then we have to check, do these answers work? X is equal to 4. Yes, it's okay in that first one because that would make it log 9. So that one's good. X is 4 works for the second one because it will be 4 take away 1, which is 3, squared, which is 9. I can have log 9. That's fine too. So that first one works out perfectly. So look at that second one. Tell me whether you think it works out. If you pause it for a second, or maybe you just look at it. Immediately, some of you are probably saying, nope, doesn't work out. Well, that's wrong. It does work out. Why? You probably looked at this first one and said, well, that works out to be log negative 2. That doesn't work out. No, it works out to log negative 2 squared. Negative 2 squared is 4. Log 4 is fine. How about the next one? This one works out to be log positive 4. That's fine as well. So we're okay with that. All right, keep going. Last one here. We have multiple of these log 8s, but on the right side I see a multiplication happening here, or an addition, which means I can multiply those arguments. So log 8 x times x plus 2 is equal to log 8, 8. When I distribute inside that bracket, we get x squared plus 2x is equal to log 8, 8. Now, at this point, the left and the right side both have base 8 logarithms. So I can put those arguments equal to each other. X squared plus 2x is equal to 8. Now we solve it just like before. Bring all values to one side. The 8 comes over. We're subtracting 8. And then I'm going to try to factor this and look for two numbers that multiply for negative 8 and add for 2. We get x plus 4 and x minus 2. If you didn't, you could use quadratic formula. But then I'm going to solve these. I'm going to get x is equal to negative 4 and x is equal to 2. So we see, do any of these ones work or not work? Well, x is negative 4. Does not work in that first logarithm at the top or the second one. So that one's inadmissible. Right, it makes that argument negative. Second one, 2, that one's okay. So there's only one root to this question here. And that's that for solving logarithm equations. As I said, it's a little bit difficult at first when you're working through them, but as you practice, they get a little bit more easier. There's only two things that we do. We try to get log of the same base on both sides. If we don't have that, convert it to exponential form. Both ways will give you the same answer. Both methods give you the same answer no matter what. But just look at how the question's given. If you log on both sides, just equate the parts of the equation that are the same. And that's that. If you have any questions, let me know, and we'll talk soon. Oh, there's questions at the bottom here too. Maybe I should mention that to practice for this section. That's it.